Hello. This is a pre-recorded lecture that I will present to second-year students at Tunku Abdul Rahman University College, Kuala Lumpur today. And the topic is, of course, universal design. The students are doing a final year project, and they are just starting design. So obviously I would try to pose these questions to the students regarding how they would tell a story. I mean, architects, architectural designers, such as the student here in the design thesis here, would need to narrate their concepts, their ideas through verbal and visual presentations. And how do they come with the concepts? They go through other concepts, precedents, and they go through the whole processes of design. So when we talk about design, we usually talk about form and function. That's the old adage that we use, that it's not only about form, because architecture is a functional art, for example, so it has to function. So when we talk about function, what do we mean by functional? To whom? And it's to the user. So we need to, at first, define design and universal design. First, design. So I'm going to go to this approach of using this quote by Kevin Martlow in his book in 2014, that design is a conversation between creativity and context. Often people think about context as in site context, but in here, context I would define as understanding people and relationships. What is site about anyway? What happens on the site is about the flow of people, activities, and functions. So you take an existing context, make sense of it, and create a new context from the existing context. The site, may it be an open site, but somehow, if there is human activities around the site or part of a larger complex of things, you're trying to make sense of that site context into a new context. And it always invariably deals with people. We learn from precedents, perhaps the type of building, if it's a visitor center, then we learn from precedents before, and we learn from the site visit. How for the designer to empathize better with the users to be, the users that will come to their programs or their architectural programs, which is to do with their building. Therefore, what is architecture but giving meaning to forms? So we just don't do forms, we have to give meaning to forms from the point of view of the user. And from the point of view of the user, facilities, when you talk about detailed design, facilities have to be functional or usable to the user. So, for example, this is a mosque in Cyberjaya where they design seating for the user to take ablution. And public transportation and community spaces on the left, benches are important for rest and transits. So again, you're thinking about the user when you design such buildings. So students of architecture, with regard to this thesis of a library, actually they have a bus terminal below and there is a library upstairs. For Connie, she developed or studied and developed the detailed design, looking at universal design as her special study. So what is universal design? Now, the second definition that we need to tackle is what is universal design. This is right off, the quotes are right off the site website below. the design and composition of an environment so that it can be accessed, understood, and used to the greatest extent possible by all people. Again, we talk about users. So universal design is very much to do with looking at this context. Yeah, the flow of activities of the people at the site, which you are creating a new context. So universal design take account of people regardless of the age, size, ability, or disability. So where there is a building on the site, it should be designed to meet the needs of all people who wish to use it. It is not a special requirement for the benefit of only a minority of the population. It is a fundamental condition of a good design, which is all about functionality. So what Connie did was actually considered the library for the wheelchair user. She had an idea of a slow, gradual ramp throughout the design, but somehow she needs to look into the details of how the wheelchair user can negotiate the library space and go through the book aisles. So the HEADS universal design, as we know it, is something that deals with about 15% of the population, as we know it. And it has been reminded by United Nations and other international agencies that you need to create an environment that is equal participation possible for persons with disabilities. In Jalan Tunku Abdul Rahman, a group of people came to from ASEAN countries, and they were doing training, and they visited the Jalan Tunku Abdul Rahman, street environment, which was done by the Kuala Lumpur City Hall to get a design that could be replicated elsewhere as well, a design that is for everyone to use. And when we think about the elderly population, there's another group of people that is in 2016 is 2.8 million, and in 2040 will be 17%. So we're looking at disabled people's estimation by World Health Organization at 15%. We're looking at almost 1/3 of the population in Malaysia by 2040 to be to those who require this universal design. It's not a design that is now considered to be just a special design, but designed for all. So the principles could be applied and everyone could use the space. So the concept of disability, as in the Convention on the Rights of Persons with Disabilities, is recognizing that disability is an evolving concept, and that disability results from the interaction between persons with impairments and attitudinal and environmental barriers that hinders their full and effective participation in society on an equal basis with others. May it be in employment, education, healthcare, recreation, cultural and social activities that regularly one does weekly or daily. So United Nations, through this convention, has defined the concept of disability where anyone could be disabled at any time in their life. As a baby, one has to have assistance from one's parents or guardians to feed and to clothe and to bathe, and then they grow to be human adults who are much more very independent, but eventually later in life there's less independence, and there need to be assisted living and finally into nursing care and so on. So this issue of impairment is that everyone will have impairment, but the environment and the attitudes need to have no barriers or minimize the barriers so that they can participate fully on an equal basis. So the idea of disability is not something that is alien, but it's something that can happen to anyone at any time in their lives. As in old age, when this is just a depiction, a cartoon that's depicting traditional houses that were built with the steep staircases and issues of aging in these type of houses, where many decided to renovate this to have access on the ground level with some concrete structures and so on. So yeah, disability is a concept that happens in one's life, at least in the later parts of one's life. And family becomes an important factor in determining the environment that we wish to create. So in a family, you have disabled persons or persons who have a bit more challenge to negotiate the environmental barriers and attitudinal barriers that happens around them. Yeah, that's where the word disability comes from. You being disabled by these barriers. If these barriers were designed to allow you to participate in life, then these barriers are eliminated, then it will ensure a much more happier life thereafter. When we talk about built environment, we're talking about the transportation vehicles, the street environment, and the building. So when we look at seamless travel, we look at there are no barriers to using pavements, and in this case, there are barriers. So it's poor design here. And the concept of the circle of mobility is from home, a point of origin, to final destination, must be seamless. For example, going through a public transport to your destination, could be a shopping mall, could be a religious building, and then go back home with the public transportation, including street environment and pavements. So a break anywhere in between will cause problems, by Peter Tan. And then we see that they are not designed like ramps that are very steep. They're not designed well to think about the user. We're going back to the user again. The slope to the market on the right is very steep, and even for people who are walking, it'd be a very difficult incline to negotiate. So these are the barriers, or these are the things that make it not seamless to travel, or make one think again or make one need to find an alternative means to access rather than to walk or to use a wheelchair. Designers are trained. We're talking about the designer and how the designer has to empathize designing for the users. So designers are trained to do good design, yeah? Not just to comply to minimum standards, but of course there are minimum standards imposed or being suggested by the government agencies. So this is just a thoughtful design of a counter where you can put your crutches or your walking stick in these grooves so you won't slip and fall. And there's a sign that says you can contact an access officer to get assistance. And in some cases, you have an enlightened early adopter developer, such as the one who did a project called Twy Residence at Setia Alam, where proactively the developer approached myself to help assist with the design appraisal and come up with type B unit, which is very accessible. So the features, 900 millimeters, small little ramps to negotiate. There's still a level difference. And knee space for built-in cabinets. This is an example of the little ramp that is by HDB Flats and little grab bars that would assist people that can be installed later. But the ramp, when you considered it earlier, it will create a seamless travel and appeal for people to use. For a foresight to design the bathroom for a wheelchair user, or you can put in shower curtains later, or you could put in glass curtain or glass barrier in. But the water, the drop or the, what do you call it? The gully, the water gully, where you won't cause water ponding, has to be in strategic corners. So the kitchen is also accessible. And these are some ideas from the HDB flats for doors to be made foldable so that although it's swerved into or swing into the space, it can still be closed easily if you're in a wheelchair in this particular instance. So a more detailed view of this bathroom, which is 36 square meters flats in HDB Housing Development Board in Singapore. Another example of HDB flat, but the bigger unit, 45 square meters, where you could actually turn around 1.2 meter corridor space. Although there's a limitation in terms of the knee space, but they consider a bigger, wider space for ease of travel, ease of entering in. And also for the 36 square meters, you can also take out the pedestal cabinet and use the sink with the knee space in there. Redesigning work, for example, thinking about how the flexibility in use could be done. One of the principles of universal design, when families use this space, this new kitchen addition. So it all boils down to the user and understanding about standards. Start from actually using a wheelchair. If you as a user, you need to use a wheelchair, but you need to also know the dimensions, the Y millimeters, which is the width from elbow to elbow when you operate the wheelchair, and from the tip of your toe to the back of the wheel, the wheelchair is the X millimeters, the length of it. So in simulation exercise that we did with students and also architects and designers, this is one of the things that is important for them to understand about this measuring tool. They do a simulation to understand the relationship between a human being and the building that they are in. They're operating the doors, operating the switches, going through the corridors, turning around. They could understand more about the space. When we talk about function, it's not only about measurements of the details or the standards of the details, it's also about space and how much space that one needs to have. So understanding anthropometrics and ergonomics, which is the work performance of someone using the space, you can see that there's some critical dimensions that one should consider. As you can see, the width from the Building Construction Authority Singapore, they suggested 680 width. And if we were to do a count, it can come to even 750, so even 800 above the width of somebody in a wheelchair using the elbows sticking out. The wheelchair itself will be different though, it will be less. So that's why we derived some of these standards of certain modules, which is 900 millimeters by 1.2 meter. And if you were to remember this module for the wheelchair user, you would understand a bit more about the basic dimension, but also you need a little bit more dimension when they have to maneuver around. So this is what you should remember. The inclination of the ramp needs to be at 1:12 for ease of independent use to get from one to another. example of in Hong Kong, example of a stage that was done in this center, and there's a MRT station which has ramps as well to access into the station area. So yeah, when you think about the user, you also think about the reachability, how they open the doors, where the ramps are, and this is Singapore standards to show that for the builder, they can have something that's temporary, a non-structural element that can be easily removed to create a ramp installation later. So the corridors have to be wide, and more than 1.2 is 1.5 corridors, millimeter width of corridors, so that they could access from one unit to another to the lift. And you can see the space in front of the door having an extra 300 millimeters door kink there, so that when you move around, not just the 1.2 by 900, but in this situation, for the ergonomics to work, you have to consider what they do, what are the movement or the area needed to complete the movement or the work performance for the ergonomics. So in Malaysian Standard, they do show the design of the accessible toilet and the different transfer that one will be doing to go to the toilet bowl, as in the case here, the MRT station. You need that space next to the toilet bowls, in front of it and at the side, so that you can have the different transfers as mentioned before in the Malaysian Standard. So MRT station accessible toilets were designed to accommodate to this situation. And then you have also the final dimensions that usually developers would follow or architects would follow so that they can comply to the standards. And these are examples of overseas, toilets overseas, where they have automatic doors, and also an interpretation of the tactile for the blind people to feel on the floor. As you can see, those embossed tactile guide using stainless steel into the floor patterns to help blind persons negotiate the space. And on the left, you see that the toilet seat has another seat for people who needs to have the height. You know, sometimes it's difficult. In the standard, you'll say 430 millimeters to 500 millimeters. So, so you have this additional equipment to accommodate for the user. People can buy this equipment if they have such problem, if they want to, or that is available in the building itself. Now, when we talk about issues for persons with disabilities and others, is the nearest possible car parking to be available to the main entrance of the building. And this is being indicated in the Malaysian Standard as well. We're going to the next session, which is on universal design principles. I'm going to go through this quickly, and this can be found in many websites, the universal design principles. And the definition is, again, I place it there on the left. So these 7 principles, when you understand what it means, you can apply this not only in architecture, in the built environment, but also in user interface, user experience, UI/UX. When you're dealing with designing for products and digital applications, technology using handheld devices. And it's even much more quicker in terms of development compared to architecture when you use universal design principles in that respect. So the first principle is equitable use. The design is useful and marketable to people with diverse abilities. So provide the same means of use. So that product has a utility and all users can use that product. So identical whenever possible. When you design that product, everyone can use the same features. But if there's alternative features, then it's fine. So like in smartphones, we have the accessibility feature that blind person can access to, or voice synthesizers or voice capabilities, for example, that it becomes equal, that they can use the smartphone just like anyone else. So you need to avoid segregating or stigmatizing any user, and so on, yeah? And it's, other features in the built environment, such as the ramp at the bus front door entrance, the flip down ramp, and access to the driver's side by everyone is also able to be done by someone in a wheelchair. This is much more equitable. But of course, equivalent means, yes, you will have access through the middle door, for example. And also the kitchenette and the washing, preparing, cooking, and all these activities can be done in one area by people who are short, people in a wheelchair, people who are standing, yeah? So that is using the principle of equitable use. The second principle is flexibility in use. The design accommodates a wide range of individual preferences and abilities. Provide choice in methods of use. So when you design a product, all the users could use their own way of using it. Yeah. If they are right-handed or left-handed, they can still use it. And this will also facilitate all users' accuracy and precision when they use it, hence providing adaptability to the user's pace in using. Scissors that are both for the left-handed and the right-handed are helpful. For example, seating and tabletop in classrooms for the right-handed and the left-handed is possible to design. Flexibility in use. If you're short in stature or you're a disabled person with limited body functions, you can have simple solutions so that they can use the cabinet and have a flip out desk area so that you can take stuff from the cabinet and display them on there, for example. So it depends on what they want this cabinet to be used on the left. And also a wheelchair that adjusts to the child's height as they grow. Simple and intuitive use is a third principle. The use of the design is easy to understand and regardless of the user's experience, knowledge, language skills, or current concentration levels. So that's, the product you can use or the architecture you can use without having to think too much, to be more intuitive, yeah? That you can get it immediately. Things like the tap, they can push the lever up and down or to the side. And a design is intuitive when people just know what to do and they don't have to go through any training to get there. When a design is not intuitive, our attention moves away from what we're trying to accomplish to how we can get the interface to accomplish what we want. So the tap handle, you want to wash your hands. So the handle is such a way that you can push it up and down. So that appeals to intuition. And also a socket and the equipment to connect to the socket and how you can use the hole in there to pull it out. So that should be intuitive enough. So the fourth principle is perceptible information. So in this case, the design communicates necessary information effectively to the user, regardless of ambient conditions or the user's sensory abilities. So when we talk about those who have sensory impairments, such as a blind person or a deaf person, these things, such as pictures, verbal, and tactile information, assist immediately in what to convey to the person. For example, signboards that perhaps on the left shows a accommodation for disabled person. That is the international access symbol for all disabled person and men and women symbol. So, and also there is a tactile braille letterings below to find out information if you need to. On the right is also a perceptible information to know where to go for parking for those who are disabled drivers. Another perceptible information is warning tiles. To know warning tiles are that which have bumps on it, raised bumps at about 5 millimeters high, easy to detect, and gives the information that is giving a warning, that they're called warning tactile guides, that there is perhaps a barrier in front or a change of level, and coupled with the person ability to hear, they would know that this is next to the road and it could be a crossing. So this will help. And on the right, there is a sign that shows the boarding area without having too many words where you should wait if you're a disabled person to board the bus in Singapore. And also information like this for the Grab driver who is a deaf person, that you could be guided by a set of instructions on how to communicate with the deaf person if you encounter one. So now the fifth principle is tolerance for error. This is to do with safety. A product has to minimize hazards and the adverse consequences of accidental or unintended actions, just falling down or getting injured. So how you have to have a design that when you arrange the elements, it will minimize hazards and errors. So the one that is mostly used, the elements mostly used, most accessible, eliminate the hazardous elements, okay, or shield or isolate it. So also to provide warnings of hazards and errors and provide fail-safe features. So for example, for a step ramp that goes to the road, almost seamlessly, one could go to the inclined and the flare side of it is done in such a way that minimizes hazards or errors as judgment in order for people to seamlessly use it. So is the bathtub, where the carer can actually sit in a position where they are comfortable to assist the small child while bathing. And there are other features around, such as grab bars, but that seating helps a lot so that there's less strain for the carer when they deal with the child and minimize her tripping or loss of balance. Principle number six, low physical effort. The design can be used efficiently and comfortably and with a minimum of fatigue. This allows the user to maintain a neutral body position, use reasonable operating forces. For some people, they are quite weak and they need to have the least effort possible when they are using something such as the lever handle, not the knob type, but the lever type of handle, door handle, so that you can, even without fingers, you can actually open the door. And also the push button type, which you just use your knuckle or even your elbow to push. Seats that have armrest that comes out also help to propel one with lower, weaker limbs to stand up on the right, and also sliding doors in the cabinets to help with low physical effort. So the last principle is the size and space for approach and use. Appropriate size and space is provided for approach, reach, manipulation, and use regardless of user's body size, posture, or mobility. So you need to provide very clear access. You can see the space and the product usually is a spatial area, and you know whether the seating area or standing area, and reach all these components easily. For example, such as shower, a cubicle where you can have a seating area in the shower cubicle, and all the equipment are reachable when you are bathing in the shower facility, or going to the accessible car park where there is an aisle where you can actually use to enter the car parking easily without, you know, with ease. There's other products for sensory disabled persons, such as blind person, such as tactile map. This is in a public building facility where they give information, and also buttons on the right in Braille, the lettering in Chinese, and also audio description in both in Chinese and English. There's also enough signs and instruction. Here we have perceptible information of who are having the priority of use for the lifts in a transportation hub. On the right, you can see again the tactile embossed stainless steel tactile guide in a building in Hong Kong. On the left, you see an area, a community area where you have places to sit easily and railing at the corridors to assist people with lower limbs that are weak. We also need to think again about the architectural designer, the architect, and how they would be able to audit or do an access audit, because they understand the user's requirement. They can go to a community facility such as sports complex and identify problems and suggest solutions to the problems. For example, proposing a unisex accessible changing room to this complex, so that you don't have someone from the opposite sex don't have to enter to the male or the female changing area, but they have a unisex changing room, which is also for the wheelchair user to use. All the facilities are there in the sports complex, including shower. And designing for public facilities such as swimming pool, you identify the problems that this complex has, and you upgrade it to different ideas. So the designer has the ability to create better living conditions, better design so that they can include all people to be able to use the facility, hence universal design. So with that, I would like to conclude the lecture, and if you have any questions, feel free to do so. Thank you very much for listening.